So if I go into our model testing evaluation section here, this is where we're now going to analyze specific AIs as part of the use cases. I did take a little bit of a different look to it to kind of match the rest of our UI, but basically the top section here has information about the model. What is it? What's its purpose? Was it using some sort of publicly available base model? You'll see a link back to the use case, as well as, I actually took this from your example, the ethical considerations that might be involved here as part of this model. This is just your kind of model card, if you will, your documentation. We then have several different analyses that we can do depending on the type of model and the information available. The first one that we have, we call the pre-training or the data set report. What this does is it uses select evaluations against the data set that's used to train the AI. Now, there's some caveats here. One, we have to have access to the actual data that's used to train the AI. And two, currently this only works with AWS's SageMaker. So we don't have integrations to ML Studio yet. If your data is stored in SageMaker and provided access to us, we'll run these different types of analysis, and you'll see that they're all bias-based. They're looking for bias in the data set. And what I mean by bias is that, in any data set of information, there's just different facets or parameters that might have a overwhelming positive or negative bias just based on the data that you have. Some examples we've seen are a positive bias towards the color purple, or another one we saw was a negative bias against softball. And you might be asking, well, that's okay, that's great. How is a bias for the color purple going to really have any effect in my data? Well, if you happen to use this model to evaluate resumes, and the person somewhere in their resumes mentions that they're a member of the Purple People Eaters baseball team, then that word purple can trigger in a just kind of random bump in their rankings because your data set was biased against purple. It sounds kind of crazy, but stuff like that happens when dealing with AI. So what we're trying to do here is just identify, is there bias in our data set before training? But like I said, there's some couple significant caveats, the biggest one being that we have to have the data set, and not all the time do you have the data set that was used to train your AI. So what a lot of our clients find more valuable is the post-training report. And this is because it can interact with essentially any AI system that's out there as long as it can somehow programmatically take queries and generate results. The example that we're looking at here is a chatbot. We prepared 135 different questions of the chatbot with expected answers. And the main goal here is to make sure that the chatbot says what it's supposed to say and doesn't say what it's not supposed to say. For example, if somebody submits a question to your online customer service chatbot of what do you think of the Trump administration, you probably want to be sure that it gives a very generic, I'm a customer service chatbot, I don't comment on politics type of answer. Because if it did start giving answers, who knows what board you're going to get up on or news article that's going to get generated. A great example of a chatbot saying things it shouldn't is the Air Canada example. A while ago, there was a customer service chatbot for Air Canada's website. A customer asked for a return policy based on a bereavement ticket. A chatbot could not find a policy for bereavement and therefore made one up. And it gave it back to the customer, and the customer went ahead and tried to basically return their ticket based on this policy, and Air Canada said that's not our policy, that was just made up, we don't honor that. It went all the way to court, and the court said, nope, your chatbot made up that policy, now you have to honor it. So it's another reason why you have to make sure that your chatbots are appropriately trained. So we got a couple of things going on here. We prepared its queries and its expected answers. And we also have the ability, again, using AI to say, look, did it exactly match what I expected the response to be? Or was the sentiment correct, but it didn't use the specific wording I was expecting? Or did it just not match at all? And what you're really kind of looking for here is more of this drift analysis. If the questions start drifting off topic, you're going to want to retrain the AI back up to an older version, kind of reset its internal knowledge, whatever you need to do in order to make sure that it gets back on track. Now, one other thing that we can do here is we can actually test for gender and racial bias. Now, there's nothing specialized in here. This is just a methodology of picking particular queries and looking at the answers. Again, in our chatbot example, I might say, hello, my name is Pete, a Western European name. And then I might start asking for my, certain questions. But then I might start another chat session with, hello, my name is Patel, using an Indian name. If I don't get the same set of answers, there might be some sort of racial bias inherent in my AI. And so we can look at the difference there of just changing certain things that would indicate race or gender and ensuring that the chatbot responds correctly. It can be helpful to understand if there's any bias in your data. Again, the big advantage here is that this can run against any type of AI that can be essentially automatically questioned. So chatbots or resume evaluation tools. Jeff and I were talking earlier about, bridge analysts design systems. All those could be used as long as there's a way to submit the data and get the results. So we can then move on to some performance metrics. And here we're looking at responses. Again, we have our 135 queries, and we're just trying to determine a couple of things here. How quickly is my AI responding? Is it responding in a reasonable amount of time? And we broke this down into two sections: the amount of time that the AI takes to calculate and the amount of time it takes to gather the data in order to have the AI make its decision. Because a lot of time when you see an AI thinking, it's actually trying to gather information, not necessarily thinking about its response. In fact, if you go to ChatGPT 5 now, certain questions you'll see it actually respond with going out to the web to get a better answer, I think is actually the phrasing it uses. And what it's doing there is it's going out to external sources and gathering data versus its own processing time. It can help you guide where to improve the performance of your AI system. The next section we qualified as accuracy, and this was taken directly out of some of the requirements from your performance specification. Now, here in my demo, I'm actually showing more than what should probably be done because it's probably impossible that you would have a single AI that does both classification and regression. But for the simplicity of just this demonstration, we have certain accuracy tests that are designed against classification models and other accuracy tests that are designed against regression style models. And what we can do is allow you to set a certain threshold for those risk levels. For example, if you want your precision to stay above a certain level, let's say 85%, if it goes above or potentially below 85%, you might want to place an alert and increase the risk, notifying you that something's wrong in the model evaluation. So we have the ability, as you kind of saw in the bias section here, where they kind of turn, warning and alerts. We can do the same thing down here. We don't have any particular threshold values here, something we can chat about maybe, but we do have the capability to set those thresholds and thus then send alerts based on those evaluations. Finally, the last section here is for data privacy analysis, and what this does is it looks through the information that was part of the data set. Again, it requires us to have access to the data set, and we're looking for key data elements, or what some would say is PII, that might have been used in this analysis. In this example, we're using email, zip code, and the person's full name. This can give you a hint as to some information that you may want to remove from your data set, because a lot of times PII should not be involved in your data set. On the other hand, we have other parts of our system that will allow you to basically alert you when somebody has requested that their data be removed from AI model inclusion, but yet we see it inside of the AI model. One of the common ones we have is email. We'll collect a list of email addresses from people that have requested that their data not be used in model training. And then if we have access to your data set, we'll scan the data set to see if that list of emails exists, and again, alert you if we see somebody's email in your data set that had requested to be removed from model training. So it's just a final check that you're complying with those people that have requested to opt out of AI model use.